So, looking at this, what fraction of this paper is shaded?
Oh, dang it, never mind.
Daniel.
1/3.
1/3. So, if I open the paper, how many equal parts are there going to be?
4.
If it's 1/3, oh, my pen's bad. If it's 1/3, when I open the paper, how many equal parts should there be?
3.
How many equal parts?
3.
3 equal parts. So now that we know that it's divided into thirds, what happens if I fold it again? John, I don't want you to yell out. We're having a problem with that. What if I fold this in half now? I want you to tell me, answer this same question at the bottom. When I open it, how many equal parts will there be? Raise your hand when you know, when I open this, how many equal parts are there going to be? What do you think, Angeli? No, I want to know how many equal parts. How many equal parts? Let's see. Preston. 2. Nope, not 2. Aaron.
6.
1, 2, 3, 4, 5, 6. 6 equal parts. Now what is my fraction? I want you to think about it before you raise your hand. What is my fraction that I'm representing now? Christine. 2, 6. So my fraction was 1/3. And now I've generated another fraction that is equal. Is this equivalent?
Yes.
Yes, it is. It's still the same amount. If this was food or brownies, remember yesterday we did brownies? If this was brownies, it would still be the same quantity, the same amount of food. It would just be now it's cut in half. Okay? Today, if you look over here on our schedule, it says generate equivalent fractions, and I just gave you an example of generating an equivalent fraction. I did it physically with a piece of paper, and we're going to be doing that in math today. So go ahead and open your book to 6-2. Patty needs 3/4 cup of dish soap to make homemade bubble solution. Her measuring cup is divided into 8ths. What fraction of the measuring cup should Patty fill with dish soap? So she wants to make dish soap. She knows she needs 3/4 of a cup, but she doesn't have a 3/4 of a cup a way to measure that. So she wants to know, how can she do this? How can she do it with her 8ths measurements? Okay, so the first thing we're going to do is compare how many 8ths are in 3/4. It says shade the model 1/4, use 4th size parts. Okay, so it says to shade 1/4. Oh, we're just trying to see how many 8ths are in 1/4. Okay, so go ahead and take your pencil and shade in 1/4. All right, how would I shade in something that's equal? If I have this little model over here that shows it in 8ths, how many am I going to shade to make it equal the size of 1/4? Raise a quiet hand when you can tell me. How many of these 8ths will I need to shade in to equal the same size as the 1/4? Raise a quiet hand when you know. If you look at it, look real quick. I did hear 4, so watch what happens if I do 4. Do you see the difference in size? Okay, so if I do just 2, this is what I get. So how many 8th size pieces do I need to equal 1/4? We just did it. How many of these to equal this? How many, class? 2. So I need 2 8th size parts to make 1/4 size part. Step 2. Now we're gonna find out how many 8ths you need to make 3/4. So the first thing I'm going to do is shade 3/4. Go ahead and quickly, you don't have to color it in perfect. Shade 3/4. Okay, remember if I looked up here, for each 1/4 piece that I used here, how many 8ths do I need? 2. So I'm going to do 2. That's 1. How many do I need to have? I have
6.
no. Well, you're right. But this is the question here is I have 3/4. So 1/4 is 2. 2/4 will be 4. And 3/4 will be 6. And I'm showing you there's that glare. So each time I do a 1/4, I'm going to need 2/8 to equal the same amount. So how many 8-size pieces did I need to make the 3/4? And how many of these pieces did I need to make these? 6. So Patty should fill how many 8ths of the measuring cup with dish soap? I want you to think about what's being asked before you answer. So Patty should fill how many 8ths of the measuring cup with dish soap to equal the 3/4 that she needs to make? Raise your quiet hand when you figure that out. What number is going to go on the top of my fraction here? What do you guys have? 6. 6/8. So Patty should fill 6/8 of the measuring cup with dish soap. Now the question that you have to think about, explain why 6 of these equals 3 of these. Why are they the same size? Use whatever words you want in your own words. I want you to explain that. And be ready to share. Okay, so the direction I think you're saying is you can divide one side by something and get the other side. Okay, it's kind of what we're going to be doing a little bit of today. Yes. Okay, and so we know that the times 2 helps us, don't we? All right, so let's go ahead and look at that on the next side. We're going to generate some equivalent fractions. So to help us. Me watch. I want you to unwrap it so that it's open, and then you can use your little paper as a something to protect so that your candy's not touching your desk. So there you go. Make it look like that. We're gonna go over a few things while we have our candy in front of us. First of all, how many candy bars do you have in front of you?
4.
No, you do not. How many candy bars do you have in front of you?
One.
Okay, you can say the answer once and then you're quiet. So we have 1 whole candy bar in front of us. I'm going to write that up there. Okay? Now, I see that you guys have already appreciated the fact that it can be broken into pieces. We are not going to break it into pieces. How many equal parts is it showing?
1.
How many equal parts?
4.
4 equal parts. Okay? How many total equal parts are still on our desk? 4. Right? So if I were to put this into a fraction, I would say 4/4. It's all there. 4/4 equals 1 whole. Every time you have a fraction with the same numerator as the denominator, you have 1 whole part. I need you to be paying attention, not talking. Every time you have a fraction with the numerator and the denominator being the same, you have 1 whole piece. It's kind of like a pizza, right? If all the pizza's still there. Now, we're going to first take this because we're going to do this problem right here. How much of this is shaded?
1/2.
1/2. Make your chocolate bar into half. Okay, so looking at our thing now, do we have a half?
Yes.
We have a half here and we have a half here. Okay? If I want to just do the part that's shaded, I'm going to remove 1 and put it to the side. Do I still have half of the candy bar?
Yes.
I actually technically have both halves, but this half is missing. So this is why I wanted you to have your paper. Let me get my shirt. So this half that was sitting right here is gone. It is not big enough. I will not do fun stuff if this is what's going to happen. All right, so now I have a half of the candy bar there. It's represented by this shaded part here. Now I need to model changing this into how many equal parts are here? No, how many? You guys keep answering the question of how many are shaded. How many equal parts are shown here?
4.
4 equal parts. I don't have 4 equal parts. I only have some of that left. But totally there are 4 equal parts, just some are missing. Okay? I can take my candy bar that I took away and break it in half. Remember, it's not there. Don't do it yet. So I can have 4 equal parts. But remember, 2 of them are missing. And what I have left are 2 equal parts here. And now I broke these in half, so this looks like this. Following?
Yeah.
Okay. I've taken those away. So looking at this, I have 2 equal parts out of 4 possible parts. So what is my fraction now? Think about it before we answer. What is my fraction that I have here? If I put this back like this, here's my total parts. I only have 2 left. What is my fraction of candy that I have? 2/4. I have 2/4. So up here it shows us 1/4 equals 2/4. Okay? Another way we can get to that is to do 1/2 times 2 gives us 2, and 1/2 times 2 equals 4. That means we made it into two parts. We took the one here and we made this one into 2 parts, and we made this one into 2 parts. So we're multiplying the whole thing by 2 parts. Okay? Now, we can do the same thing. We're going to put our candy just to the side for a second. I can change my 1/2 into 3 parts. So I'm going to change my half over here into 3 parts, which means I have to change the other side too, even though it's missing. How many total parts do I have now? I want you to think. Don't answer yet. How many total parts do I have? All right, how many?
6.
6. How many total parts are shaded? 3. So my equivalent fraction is 3/6. Don't write, just follow. The way that I figured that out, the way that I know what to multiply by here is I look at this and I changed my 1 into how many parts? How many parts are here? 1, 2, 3. I changed my 1 shaded part and turned it into 3 parts. So I am going to multiply my first fraction by 3 to get my equivalent fraction. 1 times 3 equals?
3.
And 2 times 3 equals?
6.
And I've got that. I'm just showing you that you can do it without having the model. Okay. Can I do that with 4s? Can I split my half into 4ths?
Yes.
Let's test it. Okay, shh. Oh, look at that. That's pretty good.
That's 1. Right?
Okay, so shh. Now, many of you are going to look at this and say, okay, how many total parts, be honest, how many total parts do you actually see up here?
4.
No, you actually see more.
6.
You see 6. You see 1, 2, 3, 4, 5, 6. But are we on 6th now? No, because we didn't take care of the parts that were missing. And one of the ways we can take care of the parts that are missing by taking how many parts did we split that one whole? We had one whole piece like this originally. Remember, these were together. They looked like, well, mine's apart already. But they were not one whole. They were half of the circle, and we split it into how many parts?
4.
4 parts. I'm going to do that on my half circle too so you can see it. So to find the equivalent fraction, I have to multiply 1/2 by what number? I split it into 4 parts, so I have to multiply by?
2.
No. How many ever parts I split it into is how many I have to multiply by. So 4 is how much I multiply it by. 1 times 4 and 2 times 4. What is 1 times 4?
4.
What is 2 times 4?
8.
All right, let's test it. If I take my candy, I have the 4 over here. I still have to split the other side in fourths. I mean, into 4 parts. How many parts total do I have?
8.
8, right there. How many were still left?
4.
4. There's my 4 eighths. Okay. So I didn't write in this, but we now know that the equivalent fraction of 1/2 is 4 eighths in this case. And the last one that I'm not going to be able to do with my candy because it's too small is we're going to see if we can make it break into this many parts. Go ahead and take a second on your paper. Count how many shaded parts are on this half right here. How many shaded parts are just the shaded parts right here? How many?
5.
There's 5 parts. So I've taken my half of a piece here and split it into 5 parts. To find the equivalent fraction to 1/2, now that I've divided into 5 parts, what am I going to multiply by? 5. 1 times 5 is?
5.
And 2 times 5 is?
10.
Tenths. And I'm going to go ahead and I'm going to check it out. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I went too fast, sorry. There's 10 total parts. How many are shaded? 1, 2, 3, 4, 5. Is that the same answer?
Yeah.
So I can use the model to help me find it, or I can just go ahead and multiply it out to find it. If I give you, not yet. If I give you, let's go ahead and write first. I'm going to write. How many 6, looking back at my, up here, how many 6 were there? You guys remember? 3 6. And then we had, what is this equivalent fraction? 4 eighths. And then we have
5 tenths.
5 tenths. So those are the equivalent fractions. What if I said, find the next 3 equivalent fractions? Let me give you a little hint. Stop. Let me give you a little hint. Up here we multiplied by 2, and then we multiplied by 3, and then we multiplied by 4, and then by 5. How can I find, raise a quiet hand if you can explain how I can find the next 3 equivalent fractions? Miss Sophia.
Add 1 more and just keep counting.
Not adding, I'm going to multiply. So what I did by 5 last, so my next one I'm going to multiply by,
6.
right. So multiplying 1/2 by 6 over 6. 1 times 1, I'm sorry, it's like this. 1 times 6 is 6, 2 times 6 is 12. Okay, so my next one would be 6 12s. Now I'm going to multiply by what number? 7. 1 times 7 and 2 times 7. So 7 over 14. That's my next equivalent fraction. It's okay.
1 more.
And 1 more, I'm going to multiply by
8.
8. And I'm running out of room. So 1 times 8 is,
8.
and 2 times 8 is 16.
I know.
It's a counting up by...
That's
good.
It goes by 2s and it goes by 1s.
All right, 3, 2, 1. I see a lot of light bulbs. I hear a lot of light bulbs going on. But what I want to show you is that if I'm asking you for equivalent fractions, you can find any equivalent fraction. There's tons. Do you think I can I say 50 over 100 equals a half?
Yes.
50 cents is half of $1, right? 50 over 100 is 50 cents. I mean, it's half of $1. So I can say, I can make my equivalent fraction up to the billions. I can say 500,000 over 1,000,000. That equals a half.
Whoa.
Because 500,000 is half of 1,000,000.
50 million.
So you can do an infinite amount of equivalent fractions. So when you're asked to generate equivalent fractions, you would just start thinking about the number, pick a number. Okay, I'm going to multiply by 5 to find an equivalent fraction. All right, look at the model that shows 1/2 equals 3/6. That's the second one right here. How does the number of parts in the whole affect the number of parts that are shaded? The bottom number is the number of parts in the whole, meaning how many parts were there total? But then there's only a fraction left. So, go ahead and finish drawing this in and then answer that question. There you go. I couldn't have said it better myself. The numerator is half of the denominator. Okay? If you look at all of the equivalent fractions up here, you see that that holds true. 4 is half of 8, 5 is half of 10, 6 is half of 12, 7 is half of 14, 8 is half of 16. Which is interesting because we were starting with the fraction of half. Okay. How can you use multiples to write a fraction that is equal to 3/5? I actually already explained to you how to do that. Let's see if you can go ahead and write some fractions that are equivalent to 3/5 using multiples. Now remember we did multiples last week. So use multiples. Explain how you can use multiples to find equivalent fractions for number 3, and I will let you talk with your table and fill it out at the same time. Okay. So he gave me some examples. He gave me some examples of equivalent fractions. You gave me 6/10, and what else did you give me? 12/20. Do you know which one we missed in between? There's one in between we could have done too. Does anybody know which one we could have done in between? Sean? 9/15. And then we had, 12/20. Okay, so he started by giving us equivalent fractions, and then he said he did it by multiplying by 2, and then Sean just multiplied by 3, and then Ebony also had multiplied by 4. So our multiples that we used were multiples of, just multiples of 1, basically. 1 times 2, 1 times 3. And then you can just keep finding, just like I explained up here. You can find an infinite number of equivalent fractions. All right, are 2/3 and 6/8 equivalent? Figure it out on your own this time. If I have 2 times 3, you said 3 times 2 equals?
6.
And then 3 times?
6 equals 18.
Why am I going to multiply by 6 though? Whatever I multiply the top by, I have to multiply the bottom by. So let's go ahead and go with that though, because that's okay. It's if we did 3 times 3, we see we got the numerators right, but then the denominator would have to be what? 9 to be equal. Is 6/8 equal to 6/9?
No.
No, so then this helps us know that the answer is no. And here's one example. Well, to get the numerator 6, I had to multiply by 3. So then if I multiplied the denominator by 3, I would get 9, so that would not be equal. Who did it a different way? Got no, and did it a different way. Daniel. They aren't the same size. If you actually went and did a model for them, they would not be the same exact size. Brian?
Because 3 can't go into 8, but 3 can go into 9.
Okay, so you kind of did division backwards, because you did 3 can go, because you figured that 2 times 3 equaled 6, and so you knew that this number had to be 3 times 3 equaled 9, and so you kind of said the same thing that we were saying here, just in a different direction. You went backwards a little bit by dividing, and that works too. Somebody said divided by. Who said divided by? In there, I think it was Nicholas or Christine. Okay, Christine, can you read yours for me? So 6 divided by 3 equals 2, which would be this. But 3, so then she was using the 3, but 3 times 3 equaled 9. And so I totally see how her brain is working on this. This might not be how your brain's working. It may be totally different. So if you're lost in this explanation, it's okay. But many of you, in fact, this is actually how Brian thought too, just in different words. But this is how your brain thought about it. You knew that you need 3 times 2 to get to 6. But then if we use that 3 to multiply it by the 3, we should get 9, not 8. Okay? We'll do one more that's different. Anybody want to try, Sean? There you go. Basically this thing in written out in words. I'm really proud of you guys on this. You did a great job. All right, let's look at the next side. First, they're showing us 2/3. Then they have split each one of those into half. Do you see what they did right here? They split each section into a half. So they're multiplying by what number? If we split it into 2 parts, what are we multiplying by? Remember, if I split each part into 2 parts, I'm multiplying by 2 now. 2 times 2 is?
4.
And 3 times 2 is? 6. Okay? I'm going to do the same thing here. I have 1, 2, 3, 4, 5 parts. I'm going to end up with 10 parts by cutting it in half. So basically took a pair of scissors and cut right down the middle. So I split each part into how many parts now? If this was a piece of paper, how many pieces of paper is it now?
2.
2. I just cut it into 2. So again, I'm going to multiply by 2. 3 times 2 is 6, and 5 times 2 is 10. All right, do the next one on your own. Think about, you've now cut your piece of paper. You have a strip of purple paper. You've basically cut it into some parts now. How many parts did you cut? Think of just the purple part to help you. This one little purple piece, how many pieces did you cut it into, class?
4.
We cut it into 4 pieces, so I'm going to multiply by 4. 1 times 4 equals?
4.
And 3 times 4 equals?
12.
All right, here's how you're going to do your problems today. And you can't discuss this with each other because this is something you should know. I want you to do the prime numbers. You're going to practice by doing all prime numbers. Meaning, is 2 a prime number?
Yes.
So you do it. Is 3 a prime number?
No.
Yes. So you do it. Is 4 a prime number?
No.
We get to skip it. You're going to go all the way and just through the front you do the prime numbers, and then the back, same thing, just the prime numbers.